Hello, you're watching the Next Gen Digital Infra Summit, part of our year-round DSP Leaders coverage. I'm Guy Daniels, and today's discussion looks at new cloud architectures, private clouds, and data lakes. So after a period of all-in public cloud enthusiasm, many telcos are pulling certain workloads back on-prem, and modern operator-hosted private clouds now look and feel like public clouds, containerized and API first. But what blueprints, data strategies, and operational systems are required to run them? Well, I'm delighted to say that joining me on the program to discuss these issues are Vivek Chadha, who is SVP Global Sales Head Cloud and GM Rakuten Symphony MEA, Dario Sabella, Chairman ETSI MEC and VP xFlow Software Technology, Diego Lopez, Senior Technology Expert Telefónica and ETSI Fellow, Joan Trier, who is Deputy Director and Network Architect at Docomo Eurolabs and Rapporteur of the ETSI ISG NFV, and Mark Gibson, VP Software at ConnectiviTV. Well, hello everyone, it's good to see you all, and thanks so much for taking part today. And first of all, I'd like to ask what practical steps can help telcos preserve the speed and flexibility of a cloud-native operating model once workloads are on-prem and private clouds. Vivek, can I start with you? Because you and I often have this conversation about public clouds, private clouds, and cloud native. So what's your take?
So great to be here, Guy. And I think that's a fantastic question to start the conversation today. If I can, I'd like to sum it up in the 4 C's, which is that organizations who are on the process or journey of moving from public cloud to on-prem, if they want the same kind of user experience or feel at the enterprise level, the 4 C's that they need to keep in mind are capacity. So when you provision your on-prem cloud environment, you have to do a reasonable job of understanding what your mean spikes, burst capacity needs, etc. are. And by no means do you have to limit that to on-prem. So a lot of successful transitions do utilize public cloud for certain workloads for burst capacity, but they're starting to bring in their mission critical workloads, especially the ones which are sensitive to data, etc. on-prem. So that's the first C, which is capacity. The second is around control. You can have the most accurate capacity forecasting and modeling and build your on-prem environment, including using third-party data centers. But if you don't have a good control layer or mechanism or guardrails, if you leave developers amok, they often tend to consume a lot of resources, which might not necessarily be a good ROI on investment. So you need a very disciplined set of guardrails and control mechanisms in place to ensure that your cloud capacity is being used in a robust and a reasonably governed manner. The third C is around competencies. Public cloud has had a couple of impacts on a lot of organizations when it comes to IT and digital skill sets. One of them being that for the most part, you could tend to outsource a lot of the heavy lift to the hyperscalers or the public cloud providers. But a lot of organizations still want to retain control and not have too much technical debt or dependency on their vendors. So the competency question, especially if you're doing cloud native, is how well your organization adapts to CI/CD principles, microservices, Kubernetes, etc. And do they really have a robust understanding of what it would take, not just from a technical skills perspective, but from a process and an overview point of view to integrate this new way of working when you move to on-prem. And the last one is around culture. It's very different going to a public cloud account and spinning up a couple of machines or just activating a certain set of services in your public scale, a hyperscaler account. But it's very different when you want to do it on-prem. And that culture is both around predictability, but it's also about conscious choices on how you're going to make investments in certain elements of technology, because within reason, no customer that at least we've come across wants a full-blown replica of a major hyperscaler running on-prem. It's too much firepower to solve what are relatively defined problems. So I would say in my world, those 4 C's are a fairly good framework in which you can have a fairly predictable, controlled but a manageable way to get the best of public cloud, but all the control of on-prem.
Vivek, that's great. That's a really good checklist there for everyone to go down and, as I say, establish a framework of decision making. And I really do hope we have more time to get onto the question of culture towards the end of this panel. Well, I think we should extend this topic because Vivek, you mentioned there about the split between public and private workloads. So I'd like to ask, and Dario, maybe I come to you first. Which workloads and services still make sense to keep on public cloud platforms, and how do you avoid lock-in when you're leveraging those capabilities?
Thank you so much for the question. I believe this is a very important question also to understand exactly which are the workloads that needs to be deployed depending on the needs and the convenience. Also, this is a very important question. So actually, there is a value in using, of course, any kind of cloud infrastructure, including hyperscaler platforms. But of course, depending on the workload and how this is critical, or maybe less critical from IT operation, this can be more suitable for kind of deployments from a telco point of view. Also, kind of ERP, some reporting workloads, and parts of the core network if desired by the operators. We have seen also some examples recently of a collaboration between operators and hyperscalers in that perspective. But I will also try to revert the question and think about what can be instead also the value, vice versa, of a private cloud or at the edge, right? Putting maybe, and here you may apologize me because I'm talking also as a chairman of ETSI MEC. So MEC is a multi-access edge computing. So you may understand that they have a stake in trying to explain what is the value also of the edge and the private cloud. Actually, the MEC standard, I'm chairing this big group under the umbrella of ETSI standardization, is actually introducing a standardized architecture and framework and APIs for the edge. But of course, deployment options are still a business choice. So we are back to your question, right? So again, reverting the question is, what can be the value of a private cloud or the edge? Then when it comes, for example, to real-time workloads, or the need to do some AI edge inference, or some mission-critical application, or some kind of or deal with the security and privacy of the data, then having a sovereign IT infrastructure, cloud, remote cloud, or even on-prem can be a value when you also need to take care about the privacy of the data of the users. So you see, it's a kind of choice depending on the workload and the convenience, sometimes also regarding the regulation. So answering to the last part of your question, when you asked me about avoiding the locking, yes, this is really a pain in the industry. And I believe the answer from my perspective as a chairman of a standardization body, the answer is clear, right? So we need standards to unlock the market and allow interoperability between different stakeholders. Here, the standard is the solution. Of course, in a standard group, there can be multiple players, multiple companies pushing their solution. But whenever we find a consensus and a decision for the group itself, and there is a common way to go, and this is a universally language accepted by everybody for interoperability, that helps also avoiding this kind of lock-in. Of course, it's a delicate process done with many steps, so maybe the standard is not as fast as we would like to have sometimes, but of course the process is guaranteeing kind of transparency and openness, and also in the benefit of the interoperability. So I hope I answered your question. Also, let's say, shedding a little bit of the light on what we are doing in the standard body which I'm chairing.
Dario, thanks very much indeed. Yeah, that's great. And Joanne, let's come across to you as well. This whole issue of does it still make sense to keep certain workloads on the public cloud? And as we've found recently, or the past few years of running these summits, it's not always an either-or choice. So what's your take?
Yes, certainly. I would actually answer in this way that there is no black or white case to consider. Even the cases that sometimes some applications might not be very suitable to be moved to the public cloud, operators, because of other requirements or use cases, we might need to consider, like, for example, if we need to cover use cases of disaster recovery. And we might need to actually put some workloads in the public cloud if we can actually guarantee that we can keep availability of our services. Now, when it comes to the applications or workloads that are not suitable, I think I agree very much what Dario already explained with examples. I would actually, in my case, categorize them in three different categories. One is actually on the workloads that are very latency dependent. Of course, these are not very suitable for the public cloud. And those workloads that also imply quite use of bandwidth for egress and ingress. This is also not suitable for the reason that in many cases that increases quite a lot the cost of using the resources on the public cloud. And the last category, I kind of group it into the case where there is in the workload quite a dependency on very specific types of resources that are very much coupled to the telco domain. The good benefit of using public cloud is to make use of the scale of the infrastructure that is already provided, not just only for one customer, but for many different customers. So if there is something that is required and to be customized just only for the telco domain, that makes it also not very suitable in terms of, for example, cost. Now, if we keep out all these kind of workloads, which ones are the ones that are actually suitable for public cloud? And we do have examples, these in the operators. For example, workloads that are related to operations, kind of OSS, BSS functions. There's no requirement of latencies. There is also not big, huge bandwidth usage in those applications. So these are functions that are actually quite suitable to be run also on the public domain, on public cloud, sorry. Other applications and workloads that are very suitable, consider, for example, those that are very compute intensive. Those that require a lot of compute resources might not be available to all operators to have a huge capacity. As Vivek mentioned, one of the good things to actually move workloads from the public cloud is to guarantee capacity. In certain cases, this is not possible. So still those resources that are provided by the public cloud become kind of a good source of extra capacity for the operator, in particular, as I mentioned, for the compute intensive ones. And the last category of workloads that I believe that are suitable for public cloud is also those that are more transactional, so more like business, ticketing, billing, CRM applications. These kind of applications, there is no problem at all, I would say, to be run on public cloud, of course, as long as security is guaranteed and the privacy of data is also guaranteed.
Great, Joan. Thank you. Thank you, Joan. Thank you very much for that. Well, let's move on the conversation. Let's move away from the split between public and private cloud, and let's get on to data. I really want to get a few points made on data in this particular program. I'd like to ask which architectural principles are proving most important when building modern data lakes at scale for both network and subscriber data. And Mark, let's come across to you because I think you'll have some good insights here.
Yes, thank you for a great question. It's been interesting hearing the previous response as well. to kind of shed some light on where I want to take this conversation. So I've spent 15, 20 years in the OSS software space, and every application that I've built, the first question has always been, how do I get data into this application? What are all my downstreams telling me? And typically they're multiple versions of multiple old standards, in many cases, multiple APIs, and I, to be able to understand what I'm receiving, I have to be able to translate them. So I've spent a career building adapters and building translation engines and building all sorts of ingestion processes to all sorts of downstream systems. And I just kind of accepted that that's how it was. In the last couple of years, I've started to look at the principles of data mesh architecture. And what data mesh architecture does is really kind of invert that whole conversation. It says if you're in a data domain, rather than sending your data and assuming the upstream system can ingest it, why not push it out in a format, in a pre-agreed format, which everyone upstream can subscribe to and understand and pull in. And I think when you ally that to the fact that every single operator that I've ever spoken to has built Kafka queues between all of their operational software. And so they have these queues with all this data sitting on it, but it's unstructured. It's whatever the application chose to emit is on that queue rather than it being kind of linked up. What data mesh principles, and particularly the idea of a data product, say is that when you push data onto that queue, push it on in a pre-agreed format, push it on in a structured way so that anybody who subscribes to that already knows by the data contract what that data is going to look like when it comes off. And if you do that, suddenly a lot of the things which have been complicated in the OSS space and by extension the data lake space suddenly become a lot easier. Suddenly, rather than having a data of unstructured data that everyone just goes to afterwards and says, well, it's fine, I'll go fishing in it, I'll figure out what it is. It's pre-structured. In telco, there are only so many key points that you can lock data onto. So your ports, subscriber information, numbers are all really good key points. And if you have that information in your data domain, you can quite easily push it into a common structure and then read back out of it. The other thing that I've been really struck by is how many of these kind of data buses are then queryable by SQL. So if you now have this structured common data set between, so you're just doing it in the assurance space, you're just collecting your network alerts. If they're all coming out in a common format, you can actually query the bus. You don't even really need to do any more than that. You don't have to wait for it to be ingested by an upstream system and then synced with another system which has got other data which is relevant to that decision-making process. It's kind of already there. So data mesh is still in its relative infancy. It's still starting to find its feet, but what it does do is it gives you that pre-structured and pre-organized data from multiple downstreams that could be 10, 15 years old but still operable. And I've seen a number of telco and operator architectures where they have got that. They've got 2 or 3 generations of standards, but everything's still active and it's still operable. If at that data domain edge, that boundary, you can then push everything in a common format, then your upstreams suddenly become much easier to develop. And actually then as a network and a telco operator, you can start to get towards, and this isn't saying that this delivers it immediately, but you start to move towards a common data platform across your multiple domains, or even just within a single domain across multiple historic versions of what that domain sets out, which gives you that ability to start to innovate on the data rather than having to import it into a vendor's platform and then develop on top of that. You have the data yourself, and this is a question I've been asked across my career as a buyer of your software when I was a vendor. How do I get at my data? And this starts to become the answer. You start to define your own data structure and then use the applications for their specific application, to go and do circuit design, to go and do whatever it is, to go and do data analytics. But the actual data itself is kind of pre-structured. Now, again, I don't know that we have fully fledged answer to this, but I've worked with a few exciting companies in the last couple of years who are really starting to grapple with this and really starting to think about what it means in practice to deliver these data products and how to operationalize them. And I think it's a space that certainly I'd be interested in pursuing in the standards community.
Great, Mark. We'll follow this up later, I'm sure. And then the whole idea of the common data platform we've been hunting for quite some time. Diego, I'd like to bring you into the conversation now, because I know you're doing a lot of work in this area too. What's your thoughts on the best architectural principles for managing the data at scale?
Well, basically, we are trying. We have started some work precisely on standardization and trying to find mechanisms for building. Well, we're using the terms open, distributed, and trustworthy data infrastructures, taking into account that whatever you do, whenever you're talking about computing or whatever, we are talking about processing data. It was called data processing some time ago, and I remember when I started dealing with IT long time ago, one of the first things that you were expected to do was the data models that were applicable in any case. And if you think about it, networks were as well called data networks or data communication networks, because essentially what we're moving is data. Now, with the advent of new mechanisms and closed loops and the advent even of AI, data has become more critical in the sense that it becomes the essential fluid that moves around the whole, all those cycles, etc. And what is important, I believe, is that we manage to the term that we have beginning to use is to productize data. Is the way in which whatever the data that is produced by whatever the source, whether it's a sensor, is the telemetry about a network equipment, billing data for customers, whatever the data that we produce can be shared with other parties in a way that is usable by the other party. That is productized. The example that a friend of mine uses always for this is that thing that you're producing cheese, and you're producing big cheeses, and if you decide to sell cheeses just as a whole, it's difficult that all our potential consumers are going to buy them. But if you sell the cheeses as a whole, or half cheeses, a quarter of a cheese, or a few cheese slices in a package, that makes your cheese much more edible and much more attractive to the market. The idea is to do or to go into defining mechanisms for doing this with data. So we can offer the data that is available. And as Mark was saying, it's in the telco space we can generate and consume enormous amounts of data. Is that we do this in a way that can be used by the different potential consumers and produced in a way that can be productized in that way. This is one thing. The other thing that is equally important, even more, because we're talking about things that are regulated and relate to the privacy and in general rights of our customers, is about we impose data governance. How we apply a proper data governance if we are productizing and making the data available and shareable across the network is how we can identify, define, and enforce the proper policies for accessing data, whether we are talking about humans or workloads or agents or whatever you call them that are acting on behalf of those humans, and how we relate identities and how we establish the rights for accessing and processing the data.
Diego, fascinating as well. It does occur to me that there's some great work going on here, but still a lot more work needs to be done by the whole industry. Joan, I'm going to come to you. Additional thoughts from you on this question?
Yes, I have some additional remarks maybe to add. Mark pointed out the very important aspect to actually make sure that the data is well structured. but the fact is that, as he mentioned as well, many times where we get data from, the sources of the data, there's a lot of legacy, there's a lot of different formats being used. It is quite difficult to actually assume that we can get the data into the data lake already with a specific structure or format. And I think it's very important to emphasize that we should treat the data lakes not just only like a collection of the data, but also like an opportunity to transform that data and actually make it usable, like what Diego mentioned. The importance is who is going to consume that data. So if the data has not been collected in the format that was expected or the format that is actually usable, the data lakes nowadays provide also functionalities that we can transform that data into a form that actually serves the business and the purpose for the operator. And one other aspect here is also that data needs to also be considered reusability across different domains. So, for example, in our case, it is very important to actually collect data in the access network, make it usable already to perform certain operations within that domain. But at the same time, the outputs of the operations, the aggregated data, that data needs to also actually be usable for other domains like the core or the service operations. So it is not just only the assumption that data will be consumed by one single entity. There will be different steps along the pipeline, and each one of them might make use of the data, and therefore it is important to make sure that we transform that data in different steps, in different processes in the pipeline to make it usable for the end purposes. So I think that it is important to not just only narrow down data lakes on collecting data and exposing the data, but actually the opportunity to make it usable by transforming it, by processing it in some way.
Absolutely, Joanne. Great points. Well made. Thank you very much. And we'll come across to Vivek as well. Vivek, additional points from you?
Yes, I think I'd really like what Ray just said about not just treating data lakes as a dumping ground for data, if you pardon the metaphor, but we also have the opportunity now. We're at a point where there is actually a very interesting intersection of on-prem or private cloud environments, and then the construct of data lakes or data marts. Now, where we see, for example, in Rakuten Symphony, we've built like a data AI on-prem cloud environment, a platform, which has exactly the adapters Ray was just talking about. But the approach that we're taking is that if we endlessly chase the perfect ontology of data across different departments, different domains of the telco, each domain itself has various versions of databases and different teams, etc. We will continuously be on this curve because, Guy, you started the conversation by saying we've been chasing this for many, many years. And I think this is a problem that will outlive a lot of us, to be honest, because data has many sources and uses and intersections and evolutions. So unless you try to restrict or almost prescribe a very strict regimen of data from cradle to grave, it's going to be almost impossible to dictate the formats of data over a lengthy period of time. Sure, you can get it standardized or consolidated for a period of time, 2-3 years, etc. But on a 10-20 year horizon, even the nature of your data will change. So the approach that we've started taking in Rakuten Symphony is that rather than chase the perfection of data, let's chase the intent of the internal stakeholders, the technology stakeholders who want to use this data, the business stakeholders. And the Data AI Cloud platform, for example, has data governance and data adapters built in, which try to do something very similar to what Trey just said. Not just bring data into the data lake, but bring it in a format that is very, very quickly usable by upstream systems, etc., to do the computation, to do the machine learning, etc. And I think maybe there is value in pursuing that approach in in conjunction with standardizing data and data meshes, etc., rather than a completely binary approach, which is let's try and ensure data is always pure and consistent and standardized, because that's going to be very hard to enforce even within a large organization, let alone across businesses.
Yeah, Vivek, thanks very much for this. This is a really great conversation. There's a lot of insights and ideas coming out of this. Diego, if I can come back to you, because we've already touched on data use between domains, and I'd just like to ask you, how do we ensure that data from different telco business units can get pooled together without turning into either a data swamp or data dump, as we've just heard from Vivek?
Is precisely avoiding that the heterogeneity pollutes the clean waters of the lake. Basically, seriously, the solution that we are focusing mainly is about semantics. This is, I would say, this is the other side of our data efforts. We are, apart from considering all these aspects related to data governance and being sure who can access, etc., and something that I forgot to say before, and I will remark here, is it's not only about who accesses the data, but as well to remain sure of who has produced the data. And it's about we use the term provenance for referring to this. In the case of avoiding this that the diversity is a source of problems and lack of usability of the amounts of data, we are exploring, and we have some initial results that are extremely promising, semantic models. The point is that you can have a strong agreement on the format and how you structure the data, how you use the data, but the problem is that in many cases, when you're talking about the formats, when you are calling whatever the magnitude X of the data field Y, you may be naming it in the same way into departments or two groups, but they are pointing to something that is not exactly the same, or even that they are even contradictory in some cases. What you're trying to build is mechanisms so you can share what you mean when you're talking about something and connect it with what is meant by others when they're talking about that something. Trying to look for equivalences and different degrees of abstraction and different, think about the hierarchy of categories. And you're talking about, I don't know, a service component, devices, and elements within the devices, etc. As a proof that this is something that is doable, etc., we are applying right now to the digital twins we are using for experimenting with changes or situations in our networks. And what we have done is to build a consistent ontology, semantic representation of how a network is, so people can translate what they have in operation, so we can take that representation and transform it into something that is simplified because it's running on a virtual environment, but reflects exactly what they're intending to do. The results that we have so far are quite promising. We have reduced the time of building these twins and making the assessments. We have been required to do so, and we are working in that direction. And we're trying to extend these days within the TC data in ETSI. We are trying to define or extend methodology for this kind of semantic classification that has been successfully applied basically in industrial and IoT environments. And the idea is to extend this methodology to a general case, and in particular to the case of telco infrastructure.
Very interesting, Diego. We'll look forward to updates on that later. Mark, let me bring you in for some additional thoughts here.
Yeah. So, and in response to this, I'm kind of reminded of a conversation I had when I was managing a network inventory product, and we were looking at, we modeled the devices in racks, and we could model, electricity cables coming into them. And I said to our pre-sales team, well, look, why don't we think about extending our modeling to include power and to include heating? We could easily extend our model to do that. And the pre-sales guy said, well, we could, but we couldn't sell it because we don't have any domain expertise. We understand what network equipment looks like and what interconnect looks like, but we can't talk about power or heat in any real meaningful way. So if I think then about well, okay, how do we build data lakes that aren't just unstructured swamps? Here are two super adjacent domains in the heart of any kind of network operator's system, and either one of them could be giving us an indication that there's a problem, and we could be getting alarms and alerts from both domains in parallel from their respective domain owners. But how do we kind of cross correlate them? And equally, how do we do that in a way that the upstream data scientist, who is neither an expert in telecoms or in power or heating, can then build a machine learning process to be able to kind of look across all of these data sources and other adjacent data sources and start to see deeper patterns in outright outages, outright failures, or other things which are kind of environmental. When that data is pushed into your common data set from each of those domains, it has to be scored or in some other way normalized as it enters, so that we get equivalence, so that I don't have to be an expert in heating or to understand where heating has got too much to know that actually this is okay. These two are okay and equivalent situations, but actually I can have up here two kind of ambers and maybe two reds up here, and be able to link across them and to be able to then make those additional insights that we want to be able to do with our AI processing and machine learning. So if you don't get this right at the point that the data is shared from a specific domain into a more general case, it's really hard to back infer that, because you then have to be upstream an expert in the particular downstream domain to make that inference, to make that decision. And I think this is one of the things that I've seen very recently in some conversations. That ability to within that individual domain to empower them to impose their smarts, their knowledge onto the domain as it exits their domain and is shared with other people is really important, and I think that's one of the things that you start to get with data products, and then with overlying data products, is you can then start to not only push this data out in real time with meaningful information on it, but you can then start to cross correlate in a common data stream and start to apply rules in real time in those streams to be able to put learned behavior back into the stream as the stream is progressing. And I think that's one of the really exciting things that that data mesh and data products start to bring to the fore, is that ability to sort of normalize and empower those downstream data teams to be able to add that insight in sort of semi-real time.
Thanks very much, Mark. Lots of tricky issues to sort out there. Well, we've got a couple of minutes for one final question, and I'd like to talk about culture and people, because culture was one of the 4 C's that Vivek mentioned at the start of this discussion. What organizational models successfully bridge data center facilities teams and cloud-native software groups? Joanne, can we come across to you to start us off, please?
Very good question. People is also very important in our organization. So it's not just only about technology. Well, actually, maybe I could make reference to a success story, at least in our company. What has worked out very well is actually understanding that the process of softwareizing the network is not narrowed down to any single specific domain of the network. And we have, for example, successfully virtualized the whole core network, and we are starting with the virtualization of the RAN. And it is very important to actually go to the scale of softwareizing the whole network to build teams and departments that actually take full responsibility of preparing the platform for any kind of network function. That is what, for example, we have done at Docomo. We reorganized the groups to actually make sure that there is a common infrastructure, a unified infrastructure for all the network domains. Same methodology is being used across the different domains, avoiding silos of infrastructure, avoiding silos also of management stacks. That is achievable because we have a common team that is actually preparing all this platform for, as I mentioned, all domains of the network. And actually, in the process of this transformation that is fostered by the team, it is very important to highlight also the importance of the engineers in the teams to also be trained and get the necessary skills of applying technologies that is actually facilitating them the bridging of how to deploy software with the preparation of the infrastructure. And in that case, actually, one of the success stories as well is using tooling that is very much already used in the domains of the softwareized functions to also make the management of the infrastructure. And that implies that there is cross-pollution of know-how and technology skills among different people. Those people that were only in the past focusing on pulling and plugging the cables, they can now actually nowadays understand by using other tools how to more efficiently actually make the configuration of that infrastructure that is being prepared. And that is thanks to actually skilling the people and the teams and making sure that there is a common understanding and framework being applied all across the company by having a common department and a common team that takes care of preparation of end-to-end platform across all domains. And I think that it is very important that the organization in itself rethinks about how to group and reorganize the teams to make it more efficient. And with the consideration that we are softwareizing the network end-to-end, it makes a lot of sense that there is some dedicated teams that actually take responsibility end-to-end as well of the infrastructure.
Joanne, thank you very much indeed. And Dario, will come across to you.
Yeah, maybe just a comment. I agree with the previous speakers. Just on this is a typical question, right? Where we need to understand how to improve the effectiveness of the work in operation among different teams, which are by nature looking at different level of the business. And in, for example, data center, physical facility, they are the guys who are doing the hard work and maybe different from another kind of club of software developers, guys, the DevOps more innovative. So actually, this is a really typical question in the organization, how to make them working together. There are many kind of, this is also transversal problem in the organizations. In my experience also, first of all, seeing the big picture is helping everybody to understand that even if this is not my work, I understand what the others are doing in the organization. But not just only that, experiencing on first person, like a sort of a job rotation. Some companies are experimenting this kind of possibility offered to inside the company for the organization to experience directly how maybe if you are coming from a software skill perspective and you would like to see what's happening actually in the data center facilities and vice versa. It's a kind of job rotation program. But for me, the most powerful tool also is when you kind of put in place some mechanism for shared accountability. So for the success story of the delivery itself, end to end, there should be a shared responsibility of the groups. And this is actually the key for the success, for the collaboration. There are tools also for doing that, and not just only money or just let's say like the bonus for the cross team collaboration, but the organization at the top level, the board should also kind of stimulate, encourage this kind of collaboration practically by means of a shared accountability. I believe this is also very much important for operation.
Dario, thank you very much indeed. Good place to end our conversation because we have to leave it there, but I'm sure we will continue this debate during our live Q&A show later. For now though, thank you all for taking part in our discussion. And if you're watching this on day 2 of our Next Gen Digital Infra Summit, then please do send us your questions and we'll try and answer as many as we can in our live Q&A show, which starts at 4 p.m. UK time. The full schedule of programs and speakers can be found on the TelecomTV website, which is where you'll also find the Q&A form for your question and, of course, the poll question that we ask. For now, though, thank you for watching and goodbye.